Indian Agricultural. Dr. Rama is a principal scientist at ICR, Indian Agricultural Statistics Research Institute. So basically a statistician. He did his PhD also from the same institute. And he joined ISRI as the first institute, and later in between he joined CIFE also in Mumbai for his direct selection as a principal scientist. And later he came back to ISRI so that he can do work in the major discipline. And he is an expert of all statistical procedures and a master of this R language. So we have been following R for our statistical and econometric analysis here, so that you can use it. You are not dependent on purchase of the costly softwares. So this topic, regression analysis, is mother of other statistical or econometric methods also. Very important analytical technique, even though we have been used to using it from the softwares mechanically, but Dr. Rama, he can give us more insights on regression analysis and its interpretation. So thank you, Dr. Rama, for accepting our request for delivering this lecture on regression analysis. So I would like to invite you now for this lecture. So please, the floor is yours now. You can start.
Thank you, ma'am. Thanks for the invite, and rather it is an opportunity for interacting with you all. And the topic of this training is analytical techniques for decision making in agriculture. So rather this regression, that should be the first topic for discussion as well. And when I recall my association with Rajini ma'am started when she was doing her PhD at JNU Delhi, and in the process some rough set theory method, which was a data mining method, she wanted to compare with the sort of old-fashioned logistic regression model, right? So that that logistic regression model, for that I associated with her, and again it got published in our society journal, Journal of Indian Society of Agricultural Statistics, which later I would like to mention that got the best paper award also. So that also one thing is there. Then of course Dr. Rajini ma'am, so she wanted me to share the biodata in the morning, but because I was busy in preparing these lectures, I totally forgot that. So I would like to add that for the uninitiated, CIFE Mumbai means Central Institute of Fisheries Education, and nothing routine, that usual or whatever principal scientist does as a scientist. So I was doing in statistical modeling something, and significant thing which I wanted to mention, if I would have shared the biodata with her, is only two things which I quote to my credit. One is I got the opportunity of getting training for 3 months in the field of technology forecasting at University of Houston, Texas, USA in 2011. So it has been 11 years from I'm quite old. So usually this usual cliche will be there, right? When I was at America like that and all, that we should not tell. So another thing which the system gave me was I was awarded Best Teacher Award at Central Institute of Fisheries Education, Mumbai, which is also a deemed university in 2017. So that two things we can tell. Otherwise, publications and all, I cannot compete with Rajini ma'am, right? So those things are there. Trainings and all we usually do because we do our work, right? That is part and part of the parcel of the system. So that is a thing. So now in this, I'm at present working at sort of a PME cell, right? Prioritization, monitoring, and evaluation cell. So such type of lectures only give me a sense of coming back to the thing that yes, I am also a scientist, right? Otherwise, you can tell that those things are more of a routine work. You compile all the research output of all the scientists of the institute, those things and all. So that will be more of a management work rather than this science work. So in this thing, we also learn many things, right? So while taking this lecture, we will also learn many things, right? So of course, this most of the topics are repeat. Then also some marginal things we learn while doing this. So now let me share the slide so that by 3:30 we will complete all the three things. Of course, linear regression model, I'm too much comfortable. Logit model, I'm comfortable. Probit model, I'm comfortable, but the practical session somehow for the relevant data, I could not do that. So those things, let us see how things progress. So now let me share this slide. So I hope the title slide is visible, right?
Yes, visible.
Okay. So now three things we will discuss. So now some standard textbooks are there for regression analysis. Whether the heading of this slide is visible to you all?
Yes, visible. Reference.
Right? Okay. Because for me, it is something, all those things are there, right? Mute, stop video, all those things are there, right? So
okay, no, it's visible.
It's visible. So now you can see the some standard books we follow. Of course, in this internet era, there is nothing like a we follow a book. Even anything you just Google it, you will get it. But then also these are the standard books. The third one I would like to mention, Montgomery, Peck and Vining, Introduction to Linear Regression Analysis. And the first one is also okay. It's Chatterjee and Haddy. And Draper and Smith is a very standard book on regression analysis. And for non-linear type of regression, this Saber and Weil, all these books are available at our institute library. So apart from that, for this logistic and probit, of course, I will share the lecture notes with the organizers, so you can get to know about that. So now what the topics of discussion today in this 1.5 hours is this some preliminaries. Preliminaries, when we start with regression, we should not forget to tell about correlation. Then regression model fitting, simple, multiple. That simple means there is only one independent variable. Multiple means there are more than one independent variables in a regression model, where the right hand side we have more of independent variables, and left hand side only one univariate dependent or study variable or main variable we call. And some variable selection procedures, in the sense that if there are say 10 variables for consideration to be given to the multiple linear regression, we will be selecting one most significant variables which are more of associated with the main variable. So those selection procedures. Then we will also be discussing this qualitative regressor variables, that independent variables, if they are not numerical or if they are not continuous, if they are categorical, either nominal or ordinal, then how to accommodate that. So we'll use dummy or indicator variables. So that mainly people, what they do is if low, medium, high is there, just they write 1, 2, 3 and directly give it as one variable in the model. But that is not correct. In fact, this 1, 2, 3 should be converted into zeros and ones. So that is a concept of dummy and or indicator variables that we will see. And this regression diagnostics, multipolarity detection and outliers, these are special topics under this. So what we will do, we will rush through, and when time permits, we'll come back as well. Of course, we leave this, but we will not do more on this. Then we will have the second topic, logit regression. Logit is nothing but linearized form of logistic regression. So in logistic regression also, we will have two things. One thing is why we go for logistic regression rather than the usual multiple linear regression, because when the dependent variables become categorical, that is qualitative, then the usual assumptions of the multiple linear regression does not hold root. Something like errors follow normal. Normal distribution is a continuous distribution. So errors are associated with the main variable y, variable or dependent variable. So when the main variable itself becomes categorical, errors cannot follow normal distribution because it is a continuous distribution. So this becomes discrete. So we can think of discrete distributions like binomial, Poisson and all, right? So we will be having binary, means just yes, no, presence, absent, only two levels of the qualitative variable. So we will have binary logistic regression. Then the linearized form of this binary logistic regression becomes the logit model. So when we expand that logic, it is a logarithm of the odds ratio. So that why we do that? Because the right hand side of this so-called logistic nonlinear logistic regression becomes a linearized form. The right hand side, even though the left hand side will have log of probability of occurrence to probability of not occurrence of that particular event, but the right hand side, it looks like a usual linear regression model, so it becomes logic, so interpretation becomes somewhat easier. Then we will also discuss about multinomial logistic regression, where the dependent variable will be having more than two levels of the qualitative variable. Something like I told earlier, binary means only yes, no, presence, absence. But here it could be more than two, that is low, medium, high. Or it need not be just ordinal, or gradation may not be there. Just three types. Like we will be seeing an example of something like, yes, a student is going for art stream, science stream, and engineering stream. So we cannot tell that this is better than this or this is superior to other things, right? Just we can group them. We cannot order them. So then we will be having this probability regression. Of course, probability regression is the same as logistic regression only. It is something like with the same data, both you do, many times you will get the same result, because logic model assumes a standard logistic cumulative distribution of the standard logistic distribution, and probability regression assumes cumulative distribution of the standard normal distribution. So only this difference is there. But this probability regression is, or probability analysis, they call it or don't call it probability analysis. Usually they use in these pathological studies like toxicological studies and all, like LD50, ED50, lethal dose 50, effective dose 50. That means how much concentration of the dose of the pesticide or fungicide you have to give, so that at least 50% of the insects or weeds or something gets killed. So that is LD50, effective dose 50. So 50% of the dose organisms get killed, whichever is affecting the main thing, the economical plant, whichever is affecting, like that it goes. So now, first let us, as the topic goes, it is regression analysis. The name regression, so it sounds regressive. It is something like one should always progress, and we should always talk about positive things like progression, progressive and all. But the name is regression. How it came? It all came because of the scientist Francis Galton in 1880s. He was studying garden pea experiment, where he was crossing parents who were both taller in nature. So, and separately, he was crossing parents who were both shorter in height. But what intrigued him was, whichever parents were both short, but the offspring they begot were taller than the parents. And when he was seeing the two taller parents were crossed, the offsprings were shorter than their parents. So because the offsprings were shorter than their parents, he named this phenomenon as regression rather than progression. So it is something like there are limits to growth, right? So on an average situation, it falls back. So that's why even if two parents are tall, like both are around 6 feet and all, it is not that there will be a hybrid vigor and they will beget a child who will grow into 10 feet height and all. There are limits to growth, right? So accordingly, the on an average situation, average relationship we will be discussing. And from there, this regression came into being instead of progression. And after that, it remained. So now, in order to fix ideas, we'll use this mathematics. So in high school mathematics, we would have heard about the straight line equation, y is equal to a plus bx. Say a and b are quotients. Now, in mathematics, it is 2 plus 3 is 5. But in statistics, 2 plus 3 need not be 5. It is 4.99, 5.01, like that. So we always assume a chance or error factor involved in the model, in the system, realistically. So simple linear regression, we also have this y and x, but you can see in mathematics, that straight line equation, we are converting into a statistical model by adding that error to that. Error means only small error. It is not that 2 plus 3 will become 100. That will be a very large error. Very small errors are added, which sounds realistic. So y is equal to, instead of just limiting till beta 1 x, we will always add an error to that. Y is equal to beta 0 plus beta 1 x plus epsilon. So epsilon follows this. Epsilon. So usual assumptions of the regression model are there, that the relationship between y and x should be linear. The x variables, the independent variables, are measured without error. Whatever error is there, that is associated with the main variable only. And this beta 0 and beta 1 are called unknown constants. We call parameters. Y and x are variables. Error follow. This zero mean and constant variance and normality assumption is assumed for testing purposes. It is something that whether the beta 1 quotient, regression quotient, is significant or not, or just it is a matter of chance that it is different from zero, like that. And all, we, for testing purposes, this normality assumption is needed. So under these assumptions, provided these assumptions are valid, we can use this linear regression model. Now when we go to this multiple linear regression, you can see on the right hand side, more number of independent variables are there. More means more than one. So here, how many variables are there? P variables are there. Again, the same equation I have written twice. The first time, it is the usual way of writing. Y is equal to beta 0 plus beta 1 x1 till beta p xp plus epsilon. And you can see the next, I have written the same thing, but with the suffix I. I have suffixed only to the variables. That means if we have a data set having the data points upon the variables y, x1, x2, etc., xp on n observations. N is the sample size. The data set has that much. So accordingly, will be the these whatever unknowns are there, beta 0 till beta p, they have to be estimated. How? By using the data, you are fitting the model upon the data set which is having n observations on the variables y2, xp, y, x1, x2, etc., xp. Now, when we talk of this x and y, two variables, so even more than two, one more thing comes into consideration: the relation. There is a relationship between them, interrelationship between these variables. So that is a point of interest. Just if you are taking mean, variance, and all, it is for the individual variables. But if you are talking about correlation, regression, and all, that is at least more than one variable should be there. So you would have read in the basic statistics classes and all, that correlation both ways, it is true. Correlation between y and x is same as y, x and y, and all. But in case of regression, the direction also matters. What depends upon what? It is something like, if we have two variables, height and weight, logically more will be the height, more may be the weight. So height becomes a factor or a cause, weight becomes the effect. So y will be weight, x will be height, like that it goes. Weight is regressed upon height. More the height, more will be the weight, like that it is. So not the other way. So that direction also matters in case of regression. So correlation, this whatever R codes we will be discussing in this class, I will demonstrate, but it will be anyhow shared with the organizers along with the lecture notes. R codes along with the corresponding data files will be shared, so that it will be in turn shared with the participants. So participants need not worry about this noting down, or even this PowerPoint also I will share as a PDF file to the organizers. So now, when we talk of correlation, let us start with this R. So I have, instead of using usual R, I am using the R Studio, which is a IDE environment. It will be somewhat easy for us. Now let me increase the view. I hope this will be somewhat visible. So now correlation is what? Correlation is nothing
Visible.
but yes. Correlation is nothing but the linear relationship between two variables X and Y. So why I am stressing the word linear? So that let us take in this example. So for first, let us see what is the data which we have. So this is the data which we have. So data is how it looks like. This data relates to this is okay. Something have been subtracted as well. Let me come back to the slide. So now, so let us have this equation. Y is equal to 50 minus x square. So now for what values? For the values of x from -1 till 0, then again start from 1 till 7. So how many values? 15 values are there. The relationship is y is equal to 50 minus x square. There is a relationship between y and x. Agreed? So now with this data, y is equal to 50 minus x square. So x square is 49. 50 minus x square, 50 minus 49 is 1. So in this way, the data has been generated. So now, with this data with us, let us read it inside the R. So this data we have brought inside the R software. So instead of writing D for core $X, D for core $Y, I have attached means directly I can use it. Otherwise also I am writing D for core or $Y, $X. So just I am finding the R, the correlation between the two variables. And it has come out to be this into 10 power minus 17 means it is almost 0. 10 power, that is minus 2.64 something, divided by 1 followed by 17 zeros. That means it is very, very small. It is 0. So now from the participants, can any participant tell what is going on? Even though we saw the relation between y and x in a perfect way, y is equal to 50 minus x square, but the correlation has come out to be 0. So can anybody tell what is the problem here? Any answer is the right answer. So how many participants are there? Some 81 participants are there. I have to, now our Santosh Rathod is also there from IHR Bangalore, Hyderabad, I suppose. Is there? Santosh Rathod. IARR rather, Rice Research Institute, Hyderabad. So who else are there? So attendees, they are panelists, right? From attendees I am telling, because Santosh Rathod will be giving the please tell so that we can proceed, because we have heavy agenda with us. No idea?
In between your voice
Now it is okay.
now coming.
So now I am telling, what I am telling is that whatever problem we have projected for the correlation has come out to be 0. Can any participant tell why it has come 0, even though we have y and x related? Anybody? No idea? Again, I tell the definition of correlation. Correlation quotient is nothing but a measure of linear association between two variables. I am stressing the word linear. But here, what type of association we have with us? So this is the association which we have with us, right? Y is equal to 50 minus x square.
So it is non-linear association.
It is non-linear association. It is not by association between y and x. It is association
Yes,
between
sir.
y and x square. So y and
Yes.
so they are related, but the simple correlation is 0. Agreed?
Yes, sir.
So that is the thing. So now who told this?
This is Engels, assistant professor from TNAU, sir.
Okay, Engels. Okay. So next time I can tell the name and ask, right? So,
Right, sir. Fine.
So now that's why you should keep in mind that this whatever correlation you are finding, that is giving only the linear relationships, right? So it is something like if somebody is telling two variables are independent, so that means there will be no relationship. But if two variables are uncorrelated, somebody tells, that means there is no linear relationship. Maybe that other type of relationship may be there. So it is no correlation is coming. So they are like that it goes. So uncorrelated and independent. So you should appreciate the difference. So now let us see one more data set for which both the means and variances are same. So this is the data set which particularly somebody has found out where the means and variances of these both x and y variables are all same. But you see, if you fit a regression model y upon x, if you fit that, so like this, these lines go. The first one, it appears to accommodate all the points. So it is something like it passes through most of the points, right? Then also many points are away from that fitted regression line. Errors are there, but then also it tries to accommodate all the points. In the second thing, forcefully you are fitting a linear model, linear regression line upon a non-linear type of relationship. So it does not work. The third one, you can see linear relationship is there, but there is an outlier. That outlier pulls this line towards it. That's why a perfect line upon these points we could have got, but for that outlying observation. The fourth one, you can see, again, there is an outlier, but this outlier is on the other way, extreme one. Only that time it has pulled towards that direction. You can see how much deviation we are getting. So before going for fitting any model, first we have to look into the data, how the data looks like. You have to put a scatter plot. Then we see, okay, these are outlying observation, means they are real observations, or there some typographical mistake is there, error in noting down, or a typical type of, maybe that may be true also. Sometimes outliers may be realistically happening. So in that case, you have to accommodate. But then also you should keep that this regression model only works on an average situation. So now let us see our version of the same data set. This data set, which 4 data sets I have showed: y1 x1, y2 x2, y3 x3, and y4 x4. So four data sets separately, and if you take these 11 observations rather, let us see how So I'll read that file. So once I have read that, the data has come inside the R studio. I'm attaching it and finding the mean and variance of those data sets. So means and variances have come out to be, you see 7.5, 7.5, 7.5, 7 for all the Y variables. For X variables, 9 is the mean. For this same variables, the variance is 4.1, 4.1, 4.1, 4.1. The for X, for Y and for X, it is 11, 11, 11, 11. So in this way, let us see whether this works or not. Okay, no issue. So now let us not spend more time on this. You should get the graph something like this. The same after plotting these whatever data points which we saw, we will be getting graphs like this. But you see, even though apparently initial analysis suggested that the means and variances are same, the relationship between Y and X, if you are trying to fit, so in this way it is there. So if you are forcefully fitting a regression model, it will be a disaster because the basic assumptions do not hold good except for the first one. First one, more or less, it is okay. Even though you see out of 11 points, only 5 points appear to be close to the line. 6 points are away. Then also it is okay. It tries to accommodate all the points. So in the within that range, it is there. But all other 3 data sets, the way the variation is there, they are not fit for any linear regression model. Or in the at least in the third case, you can see the outlier. If you remove, then it will be fine. In the second case, it is not y is equal to a plus bx situation. It is y is equal to a plus bx plus cx square, polynomial type of regression, quadratic relationship we call, or curvilinear relationship we tell. The fourth one, you see the x value is the same, 8. Only one example, x value is different. So when x value is the same, there is nothing to fit. We know that for whatever value will be the value of x, the y, it is changing. So now having seen this correlation and then regression in a simple linear case and multiple linear case, so we have many options available, and we also have in mind that 2 things. One is continuous or quantitative variables, which we tell in the usual scales of measurement as ratio or interval type of measurement, or we will be telling the other one, qualitative variables or predictor, categorical variables or nominal or ordinal, like that. So you see how many cases are there. If there is only one quantitative response, that is y, then univariate. If more than one, multivariate. Only one regressor or predicted variable or independent variable. Hello? Hello? Okay, excuse me. Sorry. Now this when there are parameters in the model, that is beta 0, beta 1, etc., which is having only power 1, then that is a linear model we call. We are not telling about y, x square and all. The relationship between may be non-linear, but x square can always be replaced by another name, right? X1 is equal to x square. Then also it is a linear model. Only the parameters you have to see, beta 0, beta 1, beta 2 and all, that should have a power 1. If some power 2 is there, that means it becomes non-linear. Or if it is a ratio like 1 by a by b plus c into and all, then it becomes non-linear. So in case of design of experiments model, you would have encountered CRD or RBD model, right? Y is equal to general mean plus treatment plus block or replication plus error. So there, the treatment and this replication or block, they are all qualitative variables. 5 treatments are there, 3 replications or 3 blocks are there, like that and all. So you'll be having those types, treatment 1, treatment 2 and all. So that becomes a different type of analysis. Design of experiments also you have a regression model, but there, those models we are not discussing in this class. These regression models are coming under the statistical modeling approach. So this logistic regression, by now you would have you can tell that the main variable, when it is categorical, then you cannot use the usual multiple linear regression. You have to go for logistic regression model. So one more type of models are there, which is log linear models, in which on both the sides we will have only qualitative variables. In analysis of variance and all, what happens? On the right hand side, we have qualitative variables like treatment, block, replication and all. But on the left hand side, you have the actual observations, that is continuous. But in case of log linear, even on the left hand side, that the main variable is also qualitative. So this many type of dimensions we can get, depending upon whether any variable, dependent or independent, is qualitative or continuous or quantitative. So now let us see one more data set. So this data set is a very small data set which has y, x1, x2, x3, 4 variables upon how many observations? 49 to 59. So 11 observations. So what we can fit, can we fit so given this many variables, can we fit a multiple linear regression? And if so, what will be the model which you are going to fit? Anybody? We have y, x1, x2, x3. So can anybody spell out the model which we can fit, multiple linear regression model which we can fit? Angels, help me in continuing the class.
Like at least those in the panel, they can answer some of the things. So he will know like how much.
Actually, in between, I am asking is in one more training I was giving, and then in between my connection got disconnected, right? Then it was a lot of monologue. I got disconnected and kept on telling, and after that, after 10 minutes, they told that you are not connected.
Okay, no,
So,
you are very much connected here.
In between, I have to check myself whether I am audible or
yes.
not. So that also is there. So can anybody spell out quickly if y, x1, x2, x3 are there? Then
actually chat box is also on. So those they are replying in chat box. So
okay.
They cannot basically speak. So they can only.
Okay. Sorry. Okay. Thank you.
So some cannot speak, but those in the panel they can speak.
Okay. Sorry. Okay. I did not get that point. Okay, thank you. Now with this data with us, which corresponds, so let me close this data. So these are the date information about the data is this. This I have taken from this book. Imports is dependent upon production, stock formation, and domestic consumption, all measured in these things and all. So now let us proceed for fitting a multiple linear regression and see 2 things at least. T-test and F-test. First thing I will tell you, T-test is used for testing individual regression coefficients, and F-test is used for testing the overall fit of the model, right? You also get a regression ANOVA, then always ANOVA, you know that the last column is the F. So F-test is used for getting about the overall significance of the model. T-test is used for only individual regression quotient, whether that is different from 0 significantly, statistically significantly or not. So that we are going to do by making use of this data set, this French data set. So let me bring this inside. So what we will do, we will read that data set which I showed you. So we ensure that that has come inside this R software, because the first one is here that we are not going to use in the model. I am deleting it. That first column -1 I am doing means that I am just removing it from the data set. Then let me plot it. So this is the plot I have got. So we have got this plot that is pairwise it has done. Y with x1, y with x2, y with x3. And also x1 with x1, x2 and x1 with x3, x2 with x3, all possible pairwise combinations. So what is the theory behind this? Y and x should be, x's should be related. That is, there should be more of relation between y and individual x's, and the so-called independent variables, x variables, they should be not related. So that is theoretically, but practically we will not get that much. At least we can ensure minimal relationship between the x's. It is something like number of earning members in a family, number of earning members if it is one variable, and another thing is monthly income from the family household. The more the number of earning members, the more maybe the income. So both the variables, if you include, means there will be related. X variables will be related. So one of the variable only you have to use, so to say. So now you can see y with x1. Here we can see it is related and in perfect way. Y with x2, it is related on the negative direction, but some outliers are there. Then y with x3, yes, it is related. X1 and x2. Here you can see there is a pattern, then also it is scattered. And x1, x3 exact pattern is there. That means they are more of related. x2 and x3, it is there, some scatteredness is there, so they are independent, we can tell. But then also there is a clustering, then we can ignore that. But x1 and x3, you can see the so-called independent variables are related. So this data set we will use. Now let us this library RGL I suppose, right? Let me see whether RGL is there. Okay, so now let me check it so that I can use it for this session. Having done that, let me plot a 3D graph by using this. So we have got this. So we have got x1 here, x2 here, and x3 here. Whether it makes sense, everything appears on the same line. y x1 x2. So this is the relation between y x1 and x2. Earlier what we did pairwise. So this time we are doing y x1 x2 a 3D graph. So our human eye can comprehend till this 3-dimensional, right? So this type of relationship. So now if exactly you are doing like this, means only y and x2, x1 gets suppressed. So instead of seeing this pairwise, we can also go for this 3D as well. So the main point is this regression model. LM is the linear model, that is we are going to fit a linear model, relationship between y, x1, x2, x3. So our model, so because our model y I gave, because the name from my side I'm giving. For which data? This direct data. So what is the summary of this model? So the summary of this model is this. So you can see this is beta 0, this is beta 1, beta 2, beta 3. And I told test for individual regression coefficient is done by t-test. So we can see the p-value directly it is giving. So it is something like this. Let us see the third variable. Third variable, the p-value for the t-test. T-test for the individual regression coefficient beta 3. Because beta 3 I am spelling out because it is a quotient associated with x3. The p-value has come out to be 0.026. So that means what? It is less than 0.05. Why I am telling 0.05? Because at 5% I am testing. 5% is 5 by 100. 5 by 100 is 0.05. So because 0.02 is less than 0.05, this quotient of this x3 is significant at 5%. But at 1%, because 1% is 1 by 100, that is 0.01, but this 0.02 is greater than 0.01. This at 1% it is not significant, but at 5% it is significant. So this x2 quotient is also significant, but x1 quotient is not significant, because you see from 48.8% onwards only it is becoming significant. So for 5% it is not significant, and this intercept is highly significant. So what is the R square which you have got? We have got perfect. R square is 99%. And this adjusted R square is a thing which is a function of this R square, which is used when we are comparing models. Something like we are penalizing for adding more number of variables into the model, more number of independent variables in the model, because if we keep on adding more number of variables, R square will also increase. But if you add more number of variables, what will happen afterwards? When we want to use this model for application purpose, you have to collect data on those variables also. Availability should be will be a problem, cost, efforts, time, all those things. So always we'll go for a parsimonious model where less number of variables should be there, but adequately it should represent the data. The model should represent the data. So now, having done this estimates, which we tested by individual t-test for individual regression quotient, let us proceed for finding the overall significance of the model. So for that, let me see this ANOVA of this, what is coming. So ANOVA has come out to be this, where if you see the F value for the residuals, it is come out to be.
Dr. Rama, your voice is getting little low.
So now it is okay, ma'am.
A bit better. Maybe your speaker is needs to be adjusted a bit.
I hope now it is okay.
Okay.
Okay. Maybe I have brought that laptop nearer to me, because speaker from the laptop only it has to access the whatever camera mic is there. So now it is okay, ma'am.
Okay.
Okay. So I will also speak louder. So now this ANOVA directly it is giving for individual. Let us see this F statistic. F stat this on 3 and 7. 3 and 7 means there are 3 variables, independent variables in the model, and 11 observations were there. So the total degrees of freedom is 11 minus 1, 10. So 10 minus the 3 variables is 7. 7 is the error degrees of freedom. So F test at 3 and 7 degrees of freedom has come out to be, the p value has come out to be very, very small. That is into 10 power minus 7 means it is highly significant, very highly significant. 0.00000 like that, 1. So even at 1%, it is significant. So while reporting, you will report it as less than 0.001. So the overall goodness of the fit of the model is perfect. Now, what we can do, we can use this same model for prediction purpose as well. So what we can do is whether I have brought in some for the same model. So how will you use this regression model for prediction? It is something like 11 data points are there. Means what you will do is you will keep some observations separate, hold out, we call hold out set, and say out of 11 you take usually 80-20 is the common rule. 80% of the data you keep it aside, you fit the model, 20% you use it for prediction or validation purpose. So from these 11 data points, say if you are fitting only upon the 10 data points, for 11th point you are leaving it aside. Then once the model has been fitted, so this fitted model is there. So with the quotients, this y is equal to minus 10 plus, sorry, minus 0.05 into x1 plus 0.58 into x2 plus 0.28 into x3. Once it has been fitted, you take the 11th data point, which has not been included in model fitting, just plug in the values of x1, x2, x3 only in the model. You will get some y. Y anyhow you know, but you want to predict it, so you will not give it to the model. So after doing that, you will multiply with these quotients, add this 10 or minus, subtract this 10, whatever you are getting, that will be the predicted value of y, which you can compare with the actual y. If the comparison, after comparison, the actual y and this are more closely close in that same units, then that means you can tell that that model is good for prediction purpose. So what I will do is, let us do the other way. With the same, all the data sets, with the same data set, let us predict as well. What I'm doing, I'm taking the what happened.
Yes, Thomas. ये वहाँ से यूनिवर्सिटी में वो बन गए बोर्ड मेंबर बन गए.
Here it is there. Okay.
Dr. Sunil, you want to make a point? Your hand is up. So if you want to have a point, maybe you can tell.
Ma'am, did you call me? Hello.
So the data for reg we were having. So let me come back. So using the same thing we want to predict. So what we can do, we can use this already fitted model for prediction purposes. I have included Y also, I suppose. So let me RMS it could not find. Okay, let me see this thing only. So we have got such predictions. So instead of 15.9 as the actual, we have got the predicted value as 15.67. For the actual second observation 16.4, we have got 16.92. So the difference between the actual and the predicted is called residual or fitted error. So the difference should be minimal. So it appears to be so on the same units 26.3, 26.07. So like that it goes. So the same model can be used for prediction purposes, but while predicting only you will be plugging the X values in the model of the new observations. So whatever you are getting as Y, you will be getting it as a forecast or predicted value of Y, the Y observation. So now let me come back to the slide. So we have seen T test, we have seen F test. So now next we are going to see how to choose significant variables, X variables, independent variables into the model. So there are many ways of doing things, like if there are 3 variables with you and only you have to choose the most significant variables, then you can choose it one at a time. That means 3 different models you can fit. You can choose it 2 at a time. 3C2 is again 3C1. So y upon x1, x2 separately, x1, x3 separately, x2, x3 separately. 3 at a time means all the variables, which we have done now only. Now we have done this. So now how many combinations are possible? 2 per 3 minus 1. 7 different models are possible. So stepwise regression we can use for choosing the most significant variables. We saw that x1 and x3 were related. So for the same model, let me tidyverse caret leaps. Sorry that it is not there. Third one also let us do. Okay. So now we are ready with the software, the packages, and we have installed it. We have loaded it also by putting a check mark. So now we can use the same data and we are fitting, including all the variables into the model. So I have put a dot there. That means all x1, x2, x3. So number of variables maximum is 3 and method is seek rep. So that means this stepwise regression it is doing. So others are backward and forward. So there are 3 selection procedures. One is forward selection. That means one variable at a time you are including in the model and testing whether in the presence of the already included variable, whether the new variable which you are going to include is relevant or not, or it becomes redundant. And backward means you will be assessing the importance of those variables in the model by considering that variable as if it is the last variable to have been included in the already existing other n-1 variables. And seek-rep is the syntax for stepwise regression, where it is a hybrid method. So once you have included certain variables in the models, after that, it will at every step it will go for backward selection, something like in the presence of other variables, whether this variable is relevant or not. So for this, in the background, it will be calculating correlations and partial correlations. So once the highest correlation variable will be given as a significant variable, next time what it will do, it will calculate partial correlation by eliminating the effect of the already entered variable. So like that it goes. So now let us run this stepwise regression and see what we have got. The summary. So all variables have been included. So first time one variable, then 2 variables, 3 variables and all. So more than that, let us see. Let me include it in one go. So number of variables max. So we have got R square as this. So when you are including more number of variables, as the theory goes, R square increases. But we are telling the best tuned model is when the maximum is only 2. So those 2 variables is either you do x1 and x2 or x1 and x3. So which is the final model? Let us see. Step model. So this is the final model where x1 is ignored, it is dropped, only x2 and x3 with these coefficients, with the intercept. So using this model, we can proceed. So x1 has been dropped from the model. So in this way, if so only with 3 variables you have done, you will be thinking that what is great about that. But if there are 10 variables, you should not include all the 10 variables in the model. You have to go for this stepwise selection procedure, where it will be selecting only some 2-3 variables, or at the most 3-4 variables into the model. All others will be non-significant variables. Now let us proceed. Now we can do other way as well. Instead of going for stepwise, we can go exhaustively separately fit all the models and choose the model for which R square is the greatest. So that also is one way of doing things. So you compare the R square, or I would tell compare the adjusted R square, then which is the maximum, accordingly the corresponding model will be the best. So now more than that, we can see the multicollinearity aspects as well, where I told that the so-called independent variables are related, means that means multicollinearity exists. So that is a problem. We cannot eliminate the relationship, but at least we can reduce that. So how to check whether the independent variables are related? We can go for pairwise correlations. You can see whether the determinant of that x prime x matrix, that x matrix is there now, about that all the x variables, and the rows will be the number of observations, columns will be the number of variables. So that x matrix, you can take x prime x. If the determinant is near to 0, that means it is having some multicollinearity problem. So one of the variables have to be removed. We have to recheck all those things. And one more important thing is this variance inflation factor, which determines every quotient's effect on the regression quotients. That is something like variance should be minimum, but because of this variable, the variance of that model gets inflated. Variance, you know that it is a function of error, it should be minimum, but because of that, if it is more, that means that variable have to be dropped and all. There are many other procedures. So let me see whether I have brought in this. So now that it is 3:10, we have to go to the next topic as well. So let me read data. So we have got such a data set with us. So how many variables are there? We have not only x1, x2, x3, but we have also included purposefully x1 square, x2 square, x3 square, then x1 into x2, x1 into x3, x2 into x3, and y. Of course, y is the main variable or the dependent variable. So first column is the observation column. We have removed that. What is the dimension of this matrix? 26 byte. That means 26 observations are there and 10 variables, including y. 9 variables are independent, 1 variable is dependent. So let us fit a linear regression model with all the variables in all the 9 variables, the x variables in the model. So what is the summary of fit? This is the summary of fit. We got all the quotients, but we can get a variance inflation factor for that. So let me include this. Whether now it will work. Function VAF. MC test. So this is MC test for multicollinearity test. Because I have changed the computer, it becomes a problem. So now let me see. So first this MC test has to be brought in. So certain things we have got. We have got this determinant of x prime x that is almost 0. So that means it has detected there is a collinearity problem. So other things are this condition number belongs to depends upon eigen values and all. So let me see the other one. Yes, here we have got the VIF, variance inflation factor. You can see this particular variable, that factor is very large as compared to the other variables. So that means we can consider dropping this variable in the presence of other variables. So it is a relative term, but certain variables are very small. So of course, the original x2 variable is of the things of 4 digits, but compared to the 5 digits variables, but certain variables are can be accommodated when you are squaring it. So like that, these things will give us an idea about which are the variables which are influencing more or which are to be dropped. Rather, the ideal situation, it should be near to 1 because there should be no dependencies between the x variables, but these variables add to the variance or the error to the model. So in this way, we can see this VAF and do. So now what we'll do, we'll jump to the next topic, logistic regression. So as I already told, in the logistic regression, the dependent variable should be qualitative. That means the first two things, nominal, ordinal. Only these categorical variables can be the dependent variables. Now, this logistic regression depends upon certain concepts like odds ratio, then log of odds ratio. So how to get an idea about that thing? Let us spend some 2 minutes on this contingency table, 2 by 2 table. If there are two variables, like rather I will tell attributes because they are qualitative characteristics. One is weather with 2 levels, rain and shine. Another is mood of boss, good and bad. So you can see the mood of the boss is good 82% of the time when it rains, but remaining 100 minus 82, 18% of the times it is bad. If it is sunlight shine, 60% of the times the mood of the boss is good, but rest it is bad. Under this situation, whether we see the climate or weather affects the mood of the boss. Let us see. So the ratio of the probability of an event occurring to the probability of event not occurring is called odds. Odds is what? Probability that the event occurs to the probability that it does not occur. It does not occur means 1 minus probability of that occurring. So in this previous table, what we are having? There are 82% probability that the mood of the boss will be good in case of rain. That we saw. So odds of good mood in rain category is 82 divided by 18, that is 4.5. The odds of good mood in shine category is 60 divided by 40, that is 1.5. So we can see odds from the probabilities, which is between 0 and 1, we are converting into odds, which can be greater than 1 also, 4.5 times, 1.5, these are the odds. The odds that the boss will be in good mood in rain category is 4.5. Odds that he will be in good mood in shine category is 1.5 only. So we can see the difference. So we can tell that the odds ratio of rain to shine equals 4.5 divided by 1.5 is equal to 3, indicating that the odds of getting boss in good mood during rain is 3 times those during shine. So two concepts we have got here. One is odds, another is odds ratio. So from here, how we have done, you see, when the level of a categorical value changes from this shine to rain, his mood is increasing 3 times. It is good in 3 times. So in the same way for bad mood also we can derive. So this we told that the usual regression model does not hold good when the Y is qualitative. So we have to take recourse to some other type of model. And what type of models? This is the model. 1 by 1 plus e power minus z. And z, how it looks like? Z looks in the same usual regression type model on the right hand side. But that will not be a linear model. That is given in a non-linear fashion. We see how z looks like: beta 0 plus beta 1 x1 plus beta 2 x2 plus etc. beta p xp. But directly we are not fitting that model. What we are doing? We are giving it in a non-linear fashion. 1 by 1 plus e power minus the same thing, bracket of beta 0 plus beta 1 x1, like that. So how it looks like, this is the way of the graph. The graph is looking non-linear. It is S-shaped, rather elongated S-shaped. The S letter you are stretching from both sides. It is called sigmoidal curve. And what is the beauty of this curve? The beauty of this curve is it is symmetric. Symmetric in the sense that at 0.5, halfway through it is same. And at the same time, one more beauty of this model is whatever may be the range of x between minus infinity to infinity, the range of y will always be between 0 and 1. So they can be interpreted as if it is a probability. So y values will always get between 0 and 1. So now what we can do, we can go for binary logistic regression. So rather I told this x can be between minus infinity plus infinity. I have brought in the other side as well. Instead of only on the positive side, I have brought it to the other side as well. So how it looks like, you can see. Now let us directly go to one example. Then we'll fit a logistic regression model on an on a data. So this example will let us understand the concept of logic. So I told logistic regression is a non-linear model. How it looks like? It looks in this fashion. 1 by 1 plus e power minus of beta 0 plus beta 1 x1 plus b etc. beta p. So that is a non-linear. So now what we are doing? We are taking that as a log odds. That means this pi, whatever I have written, that is probability of that model, 1 by 1 plus e power minus z. 1 minus pi will be 1 minus of the same model. So the ratio is odds. Then you are taking odds ratio. Ratio of these odds is odds ratio. Then you take log of those. So this becomes log odds. So now let us see the same model. I am taking the ratio. Then it becomes what? It becomes logic. And on the right hand side, the beauty is you will get only the linearized form, which is this much only. That is, which is z only. That non-linearity goes. Whatever will be on the right hand side, only beta 0 plus beta 1 x1 etc. But because in this example I want to discuss only one x, I have stopped till x only. So why we are going for logarithmic of odds? In order to linearize the logistic regression model. So it becomes logic. So let us take y and x. Y is what? Y is opinion towards legalized abortion. Whether abortion should be done or not. 1. Whether it should be legalized or not. 1. Otherwise, no. So let us take gender as x. Female 1, male 0. Because there it is more concerned with females. I have put a 1 to female and 0 to male. So the odds of females. How to calculate from this model? The model is what? Y is equal to beta 0 plus beta 1 x. X is gender 1. So 1 I am plugging here. So beta 0 plus beta 1 into 1. So odds of females is e power beta 0 plus beta 1. That means what I'm telling, log base C of odds is equal to 6. E power this is nothing but odds. Odds of males, I'm putting 0 here. So beta 0 plus beta 1 into 0. So that is just beta 0. So odds of males is e power beta 0. So odds ratio is how much it is coming. This divided by this. So you will get only e power beta 1. So beta 1 connects to what? Only females. So we can tell the odds ratio of female to male, that is e power beta 1. So whenever we are interpreting that quotients of a logistic regression model, we are more concerned with e power beta 1 rather than directly beta 1. In case of usual regression model, how will you interpret? Average change in y per unit change in x. But here, instead of this beta 1, we will be telling exponential power beta 1. So this you have to note down. We cannot directly interpret with beta 1. You have to tell e power beta 1 as this statement. The change in the main variable when one variable changes from female to male or male to female, like that it goes. So now let us jump into the data set. So this data set refers to the different age groups and whether they have got heart disease or not. So in this age group, where 10 observations are there, age group is around 25 years. So one person is a heart patient, others are 0. In the 30 age group, two are having some heart ailment. So as the age increases, more of ones we can see. At the age of 60, your more of ones, more of heart ailments may come, something like that. So with this model, we are relating y with x. What is y? What is x here? Y is presence or absence of a heart disease. X is nothing but the age. So simple example, as the age increases, there may be more of chance of getting heart ailment. Like that it goes. So because y is categorical, just binary yes no situation, we cannot fit a linear model. We are going for a logistic regression model. So let me read the same data. Coronary heart disease data. So now this y variable is a categorical variable, 1 and 0. So instead of reading it as 1 and 0, I am reading it as a categorical variable. So I am using a factor here. So y variable, how many zeros are there? 57. 1 means 43 are heart patients, and age is a continuous variable. So this minimum, maximum, everything is common. So X tab we can have. So this is the information in the age groups 25, around 25 years, less of heart patients are there. But as age increases, in the age group 55, you can see more of heart patients are there, less of. So now around 60, again, among the 10 observations, 80% and only 20% are not having heart. Like that it goes. Now let us try to fit a logistic regression model. So for that, we use a command GLM, generalized linear model, wherein this binomial has to be taken before a binary logistic model, logic model. So we are fitting y upon age, and I'm naming it as Ram-LR model. So once fitted, let us see what comes. So these are the quotients which you got, beta 0 and beta 1. And what is the beauty of this null deviance and residual deviance? Null deviance means when you have not included any variables in the model, this is the value, deviance value. But we have included age, it has reduced. In fact, good model, the deviance should get reduced. Now, what is so this is the interpretation. I told we should not directly take the estimate, rather we should interpret in terms of the exponential of the estimates. So exponential of the estimate, you can see as age increases by 1 unit, here not 1 unit, is 25 to 30 and all, right? So in what age groups we are considering? We are considering in jumps of 5, 25 to 30, 30 to 35 and all. So we can tell that when it is increasing, there is more chance of, it is greater than 1. So we can tell that there is more chance of occurrence of heart disease. 1.11, 1 minus of that is 0.11, that is the extra. So that we can tell. So this much time it gets increased when age increases, the heart disease, it goes from 0 to 1. 0 to 1 means absence to presence. So other tests and all we will leave. Now let us discuss only the okay. So now the next topic is on a model, logistic regression model, where the main variable is qualitative again, but is having more than 2 levels. That is, it is not just presence or absence, 2 levels. It could be more than 2, like no, medium, high and all. So there are 2 things. One is ordinal logistic, where even if they are more than it, we can have this low, medium, high gradation. You can see the intercepts are different, but the slopes, the betas are same. Or we can have a multinomial logistic regression where the main variable is qualitative and having more than 2 levels, wherein not only the intercept, but also the coefficients change. So you can see here. So in this example, let us see, let me directly jump into the example data. So let us take only program as the main variable. Main variable is qualitative. So how many levels are there? One is occasional program, another is general program, and the third one should be academic. Third one is academic. So there are not 2 levels, there are 3 levels. At the same time, there is no order here. We cannot tell that academic program is better than occasional or it is better than general and all. They are just 3 groups, 3 levels. So let us take program as the qualitative variable, and let us also take this Right is something like a GRE score they call. So 35, there's some continuous values we have. That as one of the X variables. And one more X variable, let us take, say, socio-economic status. Whether it is there from a low category, medium category, middle category, or high category. So what we are going to do now, we are having this, and three things we have. Program we take as Y, which is qualitative at 3 levels. And the X variables are 2. One is discrete, one is categorical, another is continuous. Categorical we are taking as SCS, socioeconomic status, low, middle, high. And another we are taking only the right variable, that is score, which we can take as continuous. So these three things we are going to take. Because the main variable is qualitative at 3 levels, we are going for multinomial, where we don't differentiate between or categorize was label one as superior or inferior and all. Just there are classes. So nominal data. So let me bring in the program, corresponding program. So these things I have already loaded, I suppose. This data I am reading. So we are particularly interested about program, says SCS and right. So I'm having a table here. So socioeconomic status, when it is high, they tend to opt for academic program. When it is low, all are almost one and the same. When it is middle, they tend to take academic. General is 20 and vocational is 31, like that it goes. So we can have a short analysis, but what we are interested in, fitting a multinomial logistic regression model. Now, whenever we are telling about this categorical variables, so program is a categorical variable. So always we should take one level as a base or reference category. So let us take academic as the reference category, as compared to the general and occasion, two more type levels we saw. And here again, let us consider low as the reference category. Always we'll compare with this level. If you want to change, we can change also. So let me take this as a factor. So we have ensured that academic is the reference category. In the same way, for that SCS, low is the reference category. So along with that, we will be comparing. So multinorm is the syntax for fitting a multinomial logistic regression with program, which is a qualitative variable at 3 levels, fitted upon SCS and right. SCS is a qualitative variable and right is the quantitative variable. For which data? This data. So we are fitting that model. So let me attach. I hope I have checked everything. Foreign net.
Dr. Rama,
Yes, yes.
we would finish it off as soon as possible.
Okay.
Because time.
So one thing I will do, can I get one more 1 hour, because I can stop now and then we will continue.
I think, yes, that will be better.
Okay.
So we will find out some time and I will inform you.
Okay, okay. Thank you.
But before that, because this is very important topic and it should be justified.
Okay.
Now we can take at least questions so far, whatever are there.
Okay, okay.
So, in fact, initially we planned it for 2 sessions only, but
Okay.
due to some constraint, I will inform you about the second session next week.
Okay, okay.
I have some questions. I'm sure lots of questions will be there because this topic is very dear to social scientists.
Okay.
So questions, please, if any. So there is one in the chat box regarding wall test interpretation. How to interpret wall test.
Okay. So wall test, 1 minute. Let me again share so that it will be easy for us to discuss. Yes. So this wall test is also called Z test, Z score test, which is for each of the regression quotient, whatever quotient is there in the logistic regression, we test it. And of course, this any testing of hypothesis problem has 3 things, right? One is the null hypothesis you will frame, then there will be a test statistic which you will calculate, and using that you will be the test statistics will be following a distribution under the assumption that the null hypothesis is true. Then you will have a decision criterion whether you have to reject or do not reject H0. So now you can see every quotient will be having its corresponding standard error. This ratio of that becomes this walled W, and the square of that becomes a chi-square distribution. This you know that standard normal, the square of it becomes chi-square. Now this automatically the program gives whether this is significant or not. The p-value will give. So accordingly we can check whether this beta quotient is significantly different from 0 or not. So it can be likened to the usual t-test in regression quotient in the linear regression model. But in case of logistic regression, we are using a chi-square distribution rather than the usual t distribution. So this is the thing. So now this also I will be covering when we be taking that 1 hour class. So 1 hour class, let us have especially on logit and probit.
True.
Okay.
I think that will be good. And by that time, you can have your questions also. One more question is there. How multicollinearity affect multiple regression equation?
So multicollinearity, how it affects, because the so-called independent variables becomes dependent. You know that you are fitting the model means you are estimating what? Beta 0, beta 1, beta, etc. That thing, and also the model variance. Sigma square error follows normal 0, sigma square. That sigma square, where from you are getting? You are getting from the ANOVA table mean squared error value against the error against that mean square. Whatever value is there, that is an estimate of sigma square. So if it is inflated, what happens? The actual regression is reduced because anyhow the total sum of squares is always fixed for a data. Always regression sum of square should be more, error sum of square should be less, so that the total is same. But if it is other way, what will happen? R square will decrease. So this multiplicity, what it does, every quotient, the so-called independent variables, if they are correlated, what happens is that for each of the thing we can find which one is having more of effect on the, for bringing in noise into the data. Noise means it is an ill effect. It is not a good property, multiplicity. The so-called independent variables are dependent. So some of the variables you have to remove it. Then if you are removing it, the error variance also will get decreased, reduced. And at the same time, the regression quotients which you have found out by using the method of least squares, they will be realistic. They will not have deviate from the true values of the regression quotient. So that there are two chief effects of multiplicity. One is this magnitude of the regression quotient gets deviated from their true values. Another thing is that the variance gets inflated. So two chief effects of multiplicity. So that we have to reduce. How to reduce that? There are many ways. First, you have to detect it, and after that, you have to remove also. So
Okay.
that is the thing.
One more thing is there. Maybe you would like to take that in next, or we can take it as a last question. This is, can we use proportionate data for logit and tobit, or only in the form of binary multinomial form as dependent variable?
Okay, on as a y you are telling, right? Proportional data. So proportion means it is something like out of, so in probit case and all, if there are n plants or n insects we call, then we in groups. Yeah. So if you are putting a insecticide, how much proportion has died? So out of 100 insects, if 55 has died, we can tell that 55%. So 55 by 100, R by N we call, number of occurrence divided by the total number of cases. So that we can do that example also, that proportion example also I'll bring in the next this, because now that what is expected of me, that I know, so I'll be bringing that data as well. Okay.
Okay. So I think one more question is there, whether you can take it quickly or in Q&A. This is odds ratio or marginal effects. Which value we need to consider in the logit or probit model? In Q&A.
Proportionate data, okay. One more thing.
No, in Q&A you can see below, just
okay,
below.
sorry. Okay. Odds ratio or marginal effects. Which values we need to consider in logic term? So you have to see. Marginal effects is that term I have heard, but now I am not able to recollect. Okay, because we usually interpret in terms of odds ratio. I think marginal effects also I will read and come. Okay.
Okay.
From the green book of econometrics, I will read and come.
Yes, that is a term related with econometrics, percentage change kind of thing. Yeah. Okay. I think with that, we would like to thank you, Dr. Rama, for your very long session. I know it must have been tiring for you, especially demonstrating every example, like it requires a lot of expertise, and I know you have that expertise. And our social scientists, they were very much interested in this particular session. So as desired, we will have one more session, and then we can take more questions if there are. So soon I will let you know by looking at the schedule some time for this. And as demanded by the participants, your codes and presentation may be shared.
Sure.
So then I will share with them. So I think that's all. People are appreciating in chat box. You can see it, they say it is very interesting and useful session, and they need one on logit and probit also. So that we have already told that we will have it. So Thank you, Dr. Rama, for
Thank you, ma'am. Thank you,
being
ma'am.
with
Thank
us on your holiday and managing with your home computer. I know it is difficult because we have all the material on our office desktop, so it is little bit difficult, but you made it. Thanks a lot
Thank you, ma'am.
for being with us. So now we have a next speaker also with us. He's Subhash SP. So he is basically our NIAP scientist who is on study leave to Germany, University of Bonn. And his areas of interest includes agricultural policy, institutional economics, and behavioral economics. He joined ICR in 2015.
Ma'am, shall I leave? I'll leave.
Yeah, okay, doctor.
Thank you, ma'am.
Okay, thank you. Thank you very much. You can leave. If you want to join, you can join. Dr. Subhash SP is there. Welcome, Dr. Subhash, to India.
Hello, thank you.
To India and to NIAP training. This opportunity to grab you. So I was just about to brief the participants about our speaker. He joined ICR in 2015 at NAM. You know, NAM is very prestigious institute in ICR. And before that also, he was working in international organization, CIMIT. And he has also worked in various projects in South and Southeast Asia. He did his master's degree from Punjab Agriculture University and BSc degree from Tamil Nadu Agriculture University. He is a recipient of Junior Research Fellowship from ICR also. And regarding publications, he has been publishing extensively in all international journals of which normally social scientists seek for. So he though social scientist, but he knows coding and computers a lot. Even AI is his pet theme, like where he's learning languages and employing them in social science. Some of you were asking how AI can be used in social science and all. So he can give you a lot more such applications. He has been applying that also. So today, we have invited him for his lecture on this behavioral economics. Dr. Subhash, now you can start your lecture. Thanks for being with us.
Yeah, thank you, ma'am.
Yeah. So
thanks
now,
for inviting.
Yeah.
Ma'am, how much time do we have?
Actually, we have sessions till 5:30.
Okay.
Most, so you can stop a bit early and we can take some questions also. Participants may appreciate if we end up early as usual.
Sure. Are you able to see my screen?
It is not. It has not yet come but I think it will come soon.
Okay.
Giving that indication. So far, it has not appeared. Yes, it is visible now.
Okay.
It is visible now.
Good afternoon, everyone. Thanks, Dr. Rajani ma'am, for inviting me for this session. So, as you might know, I'm planning of sharing my thoughts on using behavioral economics for designing agriculture policies. Before starting the session, I just set the ground rules for the session. This would be a bit informal. Second, you could stop me at any point of time. Third, I have a question for you. How many of you have read about behavioral economics? And especially I would ask the question, how many of you have read Nudge, the book called nudge. You could text or you could unmute yourself and speak out.
All cannot speak because some
Okay.
attending this session as attendee, but they can.
Okay. You could please text to please feel
Text.
free
You
to
can
text.
text
Yeah.
all of.
In the chat or you could put it in the chat.
Mainly in chat, all of you.
Yeah,
can,
okay.
You can repeat your question, maybe.
Okay, how many of you have heard about or read about behavioral economics, and how many of you have read the book titled The Nudge? So
There is one answer.
Okay.
No.
No. Okay. Somebody's aware about it. Okay. Aware. Okay. Okay. So even if it's aware or not, you have not read across this topic, I hope it would be interesting. Major chunk of this topic is going to be very theoretical with examples. There will be few things to be done using some data or some coding in Stata or any other software. But let me, without much further delay, let me get into the topic. Okay, so I have a question. Again, so you could text answer or just think about this answer in your mind. You are planning to buy a magazine. Okay, so you have a set of choices when you're planning to buy a magazine. Either you could buy print, you could buy a digital version of a copy. Just think about it. Which one would you prefer? Would you prefer print over digital, or would you prefer digital over print, or for you it's both the same? And just take a moment to think about it and then rank your preferences. Okay, yeah, you have responses from 1 to 3. Okay, rank the preference between print and digital. So just rank your preference. Just have it in your mind. If you're done with that, next go to this one. Now think about it. Which one would you go for? So this is something like this is advertisement there by the magazine The Economist. So I hope you could read the values here. So only print version, it's just $60 for 12 weeks. If you go with the digital version, it's $45 for 12 weeks. And if you go with both, it's $70 per 12 weeks. Okay, so the thing is that most, I assume so, also seeing from the responses, most of you might opt for 2. There is an obvious reason for it, right? Why second? Can someone respond why you opted for the second one? More choice and less value. Yeah, that's right. It gives you more choices, but the value is less. But look back into your choices before, right? Look back into your choices before. You had a set of choice. You were preferring print over digital, and or like both. But now you are indulging buying both print and digital, right? Because you look at the money and you find it catchy. And now, so you feel that, what you're doing basically here is you are maximizing your utility. You're trying to like maximize your utility by getting the maximum utility out of the money you're going to spend. But there are people who would have opted for just for the digital, and they could have opted just for the print. But if you see, and the magazine could have actually exploited this and given a lesser money for print or lesser money for digital, and get all those farmers push those farmers into getting either a print or a digital. But they are priced print plus digital in a manner it relatively finds cheaper like you find it relatively cheaper compared to all adding the both options, because you tend to add up the both options and finally pinned on thinking that print plus digital is a best option, irrespective of the set of choices you had before. You were not planning to buy print, or you were only planning to buy digital, but you end up buying both print and digital because now it sounds reasonable, right? This is what this is a strategy what company uses a lot in marketing. Company uses the they make you think this is a reasonably good offer. That's what they have done here. You actually don't know what print would cost or what a digital would cost. You could just assume that digital might be cheaper than print, and that if you want both together, it might be costlier than both options separately. But here you have an option which is, if it is charged together, it's much cheaper. This is what is that. It's like attending the same train. Okay. Sorry, I didn't get that question, but let me come to this. This is how in marketing they use behavioral principles and nudge you into behaviors you were not thought of. To be frank, what's happening here, that's what we're going to discuss in this session. I'm sorry, I'm having trouble with switching the slides.
You may unshare and share again.
Okay. Yeah.
Yes.
So,
yes, it is come.
Are there any non-agricultural economics people, like people with no economics as a background in this group, like people from extension or other disciplines?
There are.
Okay. So let me talk about some fundamental premises in which economics is built. Adam Smith, whom we call as father of economics, and his well-known book, what we call as The Wealth of Nations, which is often the book which we read when we read about Adam Smith. This is the book which we know about, and this is the book which we discuss about. So Adam Smith kind of brought economics as a different discipline from the fundamental understanding before. One of the contribution in this book is rational choice theory. Most of you might have learned about it in their undergraduation or in their master's economics, basic fundamental economics, econ course 101. So what rational choice theory means is that it's what basically we did in the first slide. It says that when we call, like in economics, every human, like every individual is assumed to be rational. Rational means, so you often ask that, okay, something could rational for me could be irrational for somebody else, but that's not how economics describes it. In economics, rational means that an individual knows his preferences, he can order his preferences, and if he orders the preferences, he actually tend to maintain that preferences if he is asked next. But from the previous two slides, we know that even we know our preferences and we can order the preferences, it may not remain so when it comes to actually buying it. So like what the fundamental assumption what economics has is that people are very rational, may not be true in many sense. People, like rationality assumes that we adopt the best action to achieve our goals, and we are logical and consistent, and we useful use of information. What happened in last two slides is that actually you don't have full information, right? When deciding on what those options are, what those preferences should be, you don't have we pick our preferences, we don't have full information about what the price is. Even while ranking it, we don't have full information on what is the relative price, or what is the price based on which we are actually ranking these commodities. That is not known. So many times we take decisions without full information. And many times we take decisions which are very irrational. And though we always take the Wealth of Nations as the Bible of economics, Adam Smith himself has written another book, which was like predating his book titled The Wealth of Economics, called as The Theory of Moral Sentiments, which actually describes a lot about how human decisions are made and how sentiments actually play a role in making those decisions. So when we build a decision model, that's the title of the training you're undergoing. What we are trying to do is building a model. A model is a true representative of what's happening there. So we use a mathematical or a statistical model to build it. So this is the basic model. What we are doing, you have y as a dependent variable. Here it is a decision. And you have set of control variables which influence this decision. And what we considered is that everything which you cannot capture in this is an error term, right? That's how you build our econometric models. Something which we should like, so we assume that everybody is rational. And if there is some inconsistencies, those are very random. The random inconsistencies, and they could be captured in an error model, like error component in the model. So the irrationalities are inconsistent, so they could be captured in, that's assumption in which classical economics is built on. So you build a model with an outcome, which is a decision with a set of characteristics, and everything else goes into error. What goes into error is basically the inconsistencies. That's how a classical economist described a model and how those classical theories are built on, assuming that individuals are rational. So we have two, but in economics, what's the subject what we are dealing with? We are dealing with human beings, right? They're basically Homo sapiens. Human beings are not built based on the assumptions of economic theories. So Richard Thaler, he's a Nobel laureate in economics a couple of years before. He classified this as two groups, one as Homo sapiens and Homo economicus. Homo economicus is a funny name he gave it to. That's a constructed human being who follows economic theories, the theories in which economics have described it. It's like human beings are building on their utility. They are like very much focused. They are very rational, but we all know that we are highly rational. We don't always try to maximize our utility. We always go with our hunch. We always go with what we think. We are very inconsistent. Many things which we feel, we will go with basically what we feel is good, rather than being a Homo economicus, economic, like how economics is, humans are described in the subject of economics. And so it could be, so if you classify them, people have started classifying as, okay, so the assumption is that humans are rational or they are irrational. There is another term called as bounded rationality. So there are different school of thoughts. The rationality belongs to the school of classical economics thought, where they assumed humans are rational. It's not tested, it's assumed every human being is rational. And any deviation from the rationality is just a random thing, inconsistencies, that's it. But there's another school of thought which they thought about, mostly from psychology. Herbert Simons came up with the thought that human beings are not rational, Rather, they are called as bounded rational. So human beings are not taking a best decision for themselves, but they are taking decisions based on few things. One is a cognitive limitation, right? We cannot do all those calculations in our mind. It's for a best decision, what we are doing is trying to optimize. So we are trying to maximize our utility given the constraints. But just think about yourself. Can you do that basically? Can we do such complicated calculation and optimize yourself and come up with the maximum utility? It's close to impossible. Humans are not like computers. So there is a cognitive limitation in which we could do. Even if we could do that, we don't do that. That's something to do with the psychological part of it. Our brain has a tendency to avoid complex calculations because we try to, if complex calculations are involved, it uses up a lot of energy. So our brain has a tendency to avoid complex calculation. So this is what they meant by cognitive limitations of the brain. As I said before, informations are imperfect. The informations what we have are not full. So we have imperfect informations. We don't know about a lot of things, but we are taking a decision. For example, you're going to buy something from a shop. Okay, was there any problem with seeing my screen?
We can see that complex screen.
Okay, fine.
No issue.
Okay, no, because I just saw a notification saying that participants could see your screen now. Sorry. So another part is that we have time constraint. So you're going to a shop buying something. You want to take a decision at that point of time, just looking at the prices. We are not going to compare across different markets, and we don't hop on different markets. We often go to a market which we perceive as the cheapest one if you're going for a cheap commodity, or we go to a shop which we consider sells good quality, because that saves a lot of time, right? So the decisions here, in this case, we are not rational. Yeah, of course, we are rational considering the cognitive limitation, the imperfect information we have, and the time constraint we have, right? So we make suboptimal decisions. They are not the best decision, but given all this information, given the setup we are in, those are suboptimal decisions. This is what Herbert Simon called as bounded rationality. So they're like, there is an alternative explanation which he came up with from a bit diverted from the economics field. We say that we don't assume people as rational. Rather just look at the decision. Rather just look at the decision and see that, is there a pattern, or like understand how they are taking the decision, not just assume it. This is another school of thought. This comes to the next question, like, you know that, right? Like waking up early is good, right? If you wake up early in the morning, it's good for us. We have a lot of time. It's a healthy habit. We have a lot of time to spend for the day, a lot of time to prepare for the day. But we all struggle to wake up in the morning. At least I do. And I see most of you guys, unless you're really good. So we all struggle to be, as a human being, it's rational to wake up early in the morning because it has a lot of benefits, but we struggle to wake up in the morning, right? We know that a good diet is good for us. Having good food is good for us, but we are always tend to temptations, right? So like, Nick, there's also another example. We all like to donate our organ, right? Like, is there like most of us, at least, I would assume that most of us like to donate our organs, but actually, how much of us have actually signed up for donation? Ponder on these questions when we're going to the next slides. All this has something to do with what we call as, or the discipline of behavioral sciences call as cognitive biases. In every decision making, the irrationality you observe, or the things which now you will start wondering, or you might have thought about it before, is because of all this cognitive biases. Cognitive biases are like very fundamental to human being. That actually affects a lot of our decision making. We know that that's the better option, but still we opt something else. So what behavioral sciences, the discipline of behavioral science, show that different from what economists thought as inconsistency. These are not just inconsistencies, they are a definite pattern to it. So the kind of biases we have, or the kind of errors we are making in such decision making, or making suboptimal decision, this is not just a random inconsistency, rather than that is like a fundamental thing to human decision making. This is ingrained in our brain, and most of us do that. That's being depicted in the examples before. We struggle to wake up in the morning, we struggle to keep up the diet, we think about good things, but we don't end up doing it. There are a lot of reasons why we don't do that, and there's a pattern in such inconsistencies. That's what behavioral economics came up with. I'll just give you a few examples of cognitive biases which explains these inconsistencies. One of the famous one now we could refer to, like we all do, is called as confirmation bias. So this is a bias with human beings. We tend to actually process or look into information or interpreting information which is consistent with our own beliefs. So like you could see from the pies in the slide, you have a set of beliefs and there is an objective set of facts. But what you tend to see is always what actually you believe. What we are trying to do is actually cherry picking and trying to prove that you're right. That's a basic human flaw. That's a fundamental bias in which in behavioral sciences we call as confirmation bias. We all do that, especially in the digital era. What we tend to align ourselves is that we always try to find something which we think is right. Warren Buffett has a famous quote. What the human being is best at doing is interpreting all the informations so that the prior conclusion remains intact. So you already made that conclusion about it. Then you try to see all the information which would actually fit into your information set or something you already believe in. That's what we call as confirmation bias. There is another, I won't call it as a bias as such, but something which exploits the cognitive bias. This is called as framing effect. Framing effect is, there's a paper by Kahneman and Tversky, who are like one of the leading pioneers in behavioral sciences, and also Kahneman got like Nobel Prize for his work in behavioral sciences in economics. What they found is that our decisions also depend upon how the information is presented to us. We act completely different if information is framed in a different manner. For example, just quote an example of McDonald's Methylene Deluxe. We don't have this product in India, but there's a product Methylene Deluxe in US, as far as I understand. They actually advertise it as 91% fat-free. There's another way of putting it out. It's 9% fat, but rather they put it as 91% fat-free. Now, looking at this product, you feel that, oh, this is good because it is 91% fat-free. Rather than if they put it as like 9% fat, you think it in a negative framing perspective. That's like how actually even the information is framed to you matters a lot. Advertisements and a lot of business does this. It's just to be from a rational perspective, both are same, right? 91% fat-free and 9% fat is both the same information, right? You should take decisions irrespective of. You should take a rational decision irrespective of how it's framed to you. But humans tend to take decisions, especially based on how it's framed to them. There is another effect called as entombment effect. That's an interesting effect because most of us are like a victim of that. Actually, we tend to overvalue something which we already own, regardless of the market value. So we don't know the value, but we assume that something which we have, we actually kind of give higher value to something which is in our hand. This affects a lot of our decision making. So like it's something for you. So this is what it's also alternatively explained. There's a counter side of it, also called as IKEA effect. Do you know, has anyone brought furniture from IKEA? I assume that you might know about IKEA. And IKEA, what does is that they will give you furniture in parts and you assemble it, right? Yeah, okay. Kirti has from Hyderabad. So why did they do that, right? Actually, it's much challenging to get in parts and assemble it. They could have just given us a assembled furniture, but they ask you to do that, right? That's why. What do you have any thoughts on why they do that? Okay. So I just take the silence as you don't have any thoughts on them. So when we do that, actually we own it. That's what they are exploiting. We kind of own it. We actually like it. It's like solving a puzzle together. We kind of value it more rather than something you just brought it without any effort, just paying the money. That's a bias. It actually doesn't make any sense if you look at rationally, but that's a bias, and we are victims of these biases. There's another bias called as anchoring bias. It's interesting. It's an interesting bias. Actually, I use a lot when you go and bargain for something. It would be interesting to know this. Could be quite useful. So there is a situation where you don't know the price of the commodity, and two people are just bargaining for it. There is a human tendency of settling the price at the price where the first guy put it out the price. For example, if I'm going to an auto rickshaw guy and asking for, okay, I have to go from Pusa to a railway station, and the thing is that if he says kitna, how much do you pay for it? If he says 100, and if you disagree to it, no, I will pay only 60. But at the end of the bargain, we always actually end up in a price which is closer to the initial price. So we will end up closer to the 100. We may end up closer to the 90 or 80 rather than to 70. That's what we call as anchoring bias. So this is a cognitive bias. Generally, people stick to the default option. There's an interesting question being asked to people. The paper is in the slides. They asked, so they first asked people, did Mahatma Gandhi live beyond age 140? Of course, everybody knows that Mahatma Gandhi didn't had his life till 140. Nobody could. So when this information, so for one set of people, they asked this information, did Mahatma Gandhi live beyond 140 years of old? Then they asked the same people, how old was Mahatma Gandhi when he died? The average answer from this response, this set of group, was 67, compared to another set of group where they asked Mahatma Gandhi lived beyond 9 years. They said, of course, he lived beyond 9 years. How old was he when he died? The average set of answer was 50. That was an interesting thing in the paper. So when you get any first-hand information, we tend to anchor around that. That's called as anchoring bias. This has a lot of implication in when we are doing studies in willingness to pay. Anchoring bias is a big deal in willingness to pay. Many times when you, even in our questions, when we ask a lot of recalled questions, like if you ask yield from last year, after asking yield from this year, compared to if you ask first the yield from last year and then compared to the yield from the current year, there is a bias in the response. It's interesting. People have studied this before. This is because of what we call as anchoring bias. This is a bias because people tend to anchor around the first kind of information provided to them. This brings back to the first slide which I've shown, the second slide which I've shown regarding pricing. This is what we had seen there is what we call as the decoy effect. The Economist magazine know that people have different preferences, and they would buy digital. And digital is much cheaper. You can get actually more people by getting more digital, but they want to sell both digital and hard copy. How they do that? So like I've just shown you. So this strategy is called as decoy pricing. Thing is that when you don't know about the information, for example, what is that reference price for Economist magazine? And we are not going to compare Economist magazine with any other magazines, right? So if you're, for example, I have a photo here. So of 2 wine bottles, one is priced $10 and another is priced $30. So now you think $30 is expensive, right? You have 2 alternatives and one is 30. It's pretty expensive. But what usually companies do that as a pricing strategy using this effect called as decoy effect is add another bottle which has a higher price, like $50. Of course, nobody is going to buy a wine bottle for $50, but now you think 30 is reasonable, right? That's what happened. That is one of the explanations for why you opted for digital plus the digital plus print compared to either digital or just print, because now you think this sounds to be a reasonable price, right? Because if I add them together, that's much costlier than actually having them having them separately. Or now you think that digital is like you might have liked digital, but $45 for 12 weeks is pretty costly for you. Even if you liked digital, you might not opted and gone for print. But now, because both of them look cheaper together, you're opting for something. Here, they are employing the strategy of decoy pricing, so that they're kind of changing your way of thinking. They are kind of changing your decision making, the way in which you take decision. There is another example which makes sense for our discipline. This is called a status quo bias. We actually prefer to stay in a way how we are. Like there's a huge inertia among us. Though in extension, you have this adopter, non-adopter, Roger model. But in reality, many times people are a bit, except few of them, most of them are very, very biased towards remaining in status quo. Any change is a bit challenging for us, right? Though we know that that change could be beneficial, but we tend to stay or lazy around and stick to the way we are. This is a status quo bias, which many people exploit in marketing, but this is something which you should know. Such biases exist in decision making. So what could we do? Okay, we know about these biases. We know that fundamentally human beings may not be very rational or perfectly rational. And we know that there are a lot of such biases associated with it. So what could we do? One of the fundamental problem which behavioral economists put it out is that we are thinking humans as a construct developed by an economist, right? But we are dealing with humans. Humans have such biases. So when we want to make policies or make interventions, that should be behaviorally smart. When we say behaviorally smart, you should remember that we are going to design policies for humans. That's something which you need to keep in mind, not to the construct of like assuming everything is rational, rather than understand how humans behave and how to make policies out of it. So like, but to wake up early in the morning, you have this alarm clock, but you often, you have it in mobile. Nowadays, nobody uses alarm clock. You have it in mobile, but you often tend to snooze them, right? Because it is easy to snooze it and just go back to the bed. But there is a device now called as Clocky. Clocky is, what it does is it's an alarm clock. It will first, so you could set it up. What it does is that it will move around in the room. After the first alarm rings, it will move around in the room. You have to actually wake up and find it, because it has a way of moving around and getting lost somewhere. Actually, it won't be there in the place where you left. So you have to literally wake from your bed and then find it. That basically helps in like getting out of your sleep. With diets, they found out really interesting insights, which you could also try. Is that if you keep smaller plates, so if you see these plates, actually the food in both the plates is of same volume. But if the plates are bigger, if you're opting for a smaller plate, you actually tend to, your consciences tend to think that there is a lot of food in the plate. So you could actually cut down the food by just opting for smaller plates. That's a very simple solution, right? Just cut down the size of your plate. So you feel that you're eating a lot of food. That one actually cut down and helps in avoiding overeating. With organ donations, there's an interesting idea which is being used. Is actually making everyone in the country default for organ donation. It's like most of the people actually want to donate organ, but we don't do that because the process is complicated, right? Who will go and do that? Actually, most of us have no idea how to even do that. Even we might have Googled about it, but we have like, yeah, we'll do it at some point of time. So what in many European countries, what they did was that everybody in the country by default is an organ donor, but you can opt out of it. So if you don't want to do that, you can opt out of it. So if I really don't want to donate my organ, of course I will go and opt out of it, right? So that's an easy way, setting up a default, because this could increase organ donation. Though practically there were a lot of other challenges to this, but so these are like, we could design interventions or policies in much behaviorally smart ways, right? This were the examples which are referring to clocky, changing the dinner plate size, and setting organ donation as default. This brings back to the concept what Richard Thaler was giving out. Richard Thaler and Cass Sunstein wrote a book titled The Nudge. If you're interested in reading books, you should read that. This is a really interesting book to read among various books which I've written. So nudge, what their argument is that you could actually, the literal meaning of nudge, right? Like it's like giving a nudge. We can actually, if we understand people's choice architecture, the choice architecture means that how people take decisions. We could actually change their decisions without any change in their economic incentives. So let me say, like there are, these two end of spectrums, right? If you want to bring some change in the society, let's talk about the most controversial recent let's leave it. Let's not get into controversies. Let's take about agriculture policy, right? There are two ways of doing it. One is laissez-faire. Laissez-faire is like go with the markets, let demand, supply, and all other market forces govern the decision. Second is fixing up mandate, like a mandate is like MSPs. MSP is not a mandate, but you should sell this commodity here. It's like setting up a mandate, which kind of actually helps sometimes. Or like there is another spectrum in this, you are kind of incentivizing it, right? Like giving MSP, you're trying to incentivize it. These two are like on two end of the spectrum, right? Laissez-faire is not, we are not interfering with their decision making. On the other side, we are completely interfering in their decision making by setting up mandate, and in somewhere in between is actually incentivizing it. So we're not directly interfering in their decision making, but rather we are using incentives to change their decision making, right? But what nudge means is that we are changing their decisions, but keeping the options open, right? Like setting up defaults for organ donation, right? So we are not giving any incentives. We are not taking away their options. If you don't want to donate organs, you could opt out of it. But here, that humans are basically lazy, and most of them want to donate organ. So just set it as default. That's much easier, right? This is an easier way of like what we call as nudge. they're like this actually kind of revolutionized how we think about policies. Most of the countries now have something called as a nudge cell or behavioral cells. So they use this in policy. The catch of the nudge is that in most cases, this is pretty cheaper to implement. You know that incentives are costly. We have to, for example, MSP is pretty costly, right? And setting up a mandate is actually has a lot of transaction cost. What I mean by transaction cost is protest from farmers, your political capital is under threat. So that's a bit challenging. And laissez-faire, you never know how it works or not, and you may not get the right outcome which you decide as a policymaker. In case of nudge, you are getting your desired outcome, but without spending much money. An example of nudge is default. Default for organ donation. So what we did there, we did nothing. We didn't provide any incentives like paying money for actually donating organ, or we are making it mandate that everybody should donate organ. Rather, we just set it as a default. So what they call this is as libertarian parentalism. So what we are doing is we are keeping this option open, but kind of nudging them into doing it, right? This often in policies doesn't have any economic. There's much cheaper to do nudges if the nudges work. Let me quote that: if most nudges could or could not work, and many times humans are pretty smart. We know that hey, we are being nudged. We actually could opt out of that nudge, or we know that we are being nudged and we may not change our decision making. That's possible. This is a concept given by Richard Thaler and Sunstein, and there's a whole new interest around this. Even now, Niti Aayog has a nudge unit. So in India, it was pretty bit late, but now we are thinking about using this behavioral sciences in our policies. We have few policies which actually already used it to some extent, like give it up for LPG subsidies. So they didn't ask us. Right? So they actually didn't ask. They didn't make a mandate. Rather, they just made an advertise that like give it up. That it's good for the nation. So it's building on your behavioral biases and actually implementing, saving some money for the government. So this is a list of countries which are using now nudge. India is not still there because this one is compiled from 2018. India started thinking about set up a nudge unit in around 2019. It was thought about in 2020. They had something in mind. I think by 2021 they now have a nudge unit which they are working with. I think it's based in. They are working in collaboration with Ashoka University. So in actually Economic Survey 18-19, there was a chapter dedicated to using behavior or economics or in nudge. And the classification they have provided is not exactly true. There is some inconsistencies in it, but just forget that from an academic perspective. What we know is that there's a great interest around it, right? Like there's a great interest around using this behavioral economic principles into policy, which has not thought before, or which has gained a lot of momentum and traction in recent years. Okay, do you have any questions at this point of time? It's really weird because nobody can open up a communication and ask it straight. But do you have any questions at this point of time, or should we move ahead with the presentation?
They all are enjoying it, but
okay. I hope so. Okay, I hope so. Or it's just Saturday evening and you're done for the week. Okay, we'll go ahead and think about now. So far, what we had discussed is very basic theory. Let's think about now. Now the question is, okay, that all sounds good. How are we going to use it in our field, right? In agricultural economics, or like, let me say, agriculture sector as a whole. How we are going to use these principles, right? people have used it. And so people have looked into, it's not like, this is not a silver bullet. You cannot use it everywhere. Like, hey, I want to do something. Can we use behavioral insight or this principles? No, it won't work everywhere. And people have tried using these principles and looked into how the results are. One thing which I discussed is about like influencing decision making power of farmers, like especially with and new technology. We often think that, okay, the common thing we do is like running regressions and finding which are the factors which influence the farmer's decision to select a variety. It could be like age and education is always a significant factor, and with number of other factors. But if you go back to a policymaker, what you could do with those significant results? You can't do anything about age. Of course, education matter, but you could do nothing about it. Can we? Yeah, you could bring some additional education to the farmer about the varieties. One of the fundamental thing which we are getting it wrong is that we are assuming farmers are maximizing utility. That we are assuming that farmer knows that if he adopts a higher variety, he gets higher yield and higher income. We assume every farmers know that. This is a rational decision, right? If a new variety is in the market, he should adopt it. That's a flaw in our assumption. That we assume, as we know, there are a lot of factors actually influence someone's decision making, and we are all biased in many ways. That includes, when we say we, it includes farmers too. It's fundamental to what we are, right? So let's see some examples of how actually people used behavioral insights into changing the policies. So when we say this is not just an idea, right? You can't just have, okay, this could work. But as a researcher, what we do is that if you think it could work, we'll go back and test it. We'll come to the testing part after the session, but that's what we are supposed to do. So we think this theoretically this should work, then you test it. So this is an interesting study done by Esther Duflo and Michael Kramer and Robinson in Kenya. Both Esther Duflo and Michael Kramer got Nobel Prize last year for the same work. They got it for RCT using randomized control trials. But what they used in this RCT is actually testing for a behavioral, they have used a behavioral bias, exploiting a behavioral bias by nudging farmers into using fertilizer. We know that farmers actually, if you add more fertilizer, this is not case of, we are not talking about India, we're talking about Kenya, where though we know that if more fertilizer would keep more yield, they tend to actually put less fertilizer. One of the reasons is that farmers actually, immediately after the harvest, they have money with them, but often they don't. So they have money at their hand. They know that they're going to sell, sow crops next season. They need to buy fertilizer, but they tend to procrastinate. And what often it happens is that because of procrastination and because of all other things happening, you tend to spend that money into something else. At the end, when you are just before the season, you have little money to actually buy fertilizer. So they actually found a way to nudge farmers and buy fertilizer just immediately after harvest. So they have tested this different ways in which they could nudge farmers, and they found out that if there is an early home delivery of fertilizers, like immediately after the season, the fertilizer use actually went by 70%. This is actually, so what they did was that, of course you would say, yeah, if I get to go home delivery, that's a better option, everybody would buy it. But what they did is that they combated with actually subsidizing fertilizers. So the common idea what we do is basically subsidizing fertilizer and see farmers would buy more fertilizer and apply to it. But when they compare it with just providing home, it like directly to their home early in a group versus in a group with subsidized fertilizer, they found out that the people who actually got home delivery used more fertilizer compared to actually who were like subsidized and asked to get it from market. That's an interesting study because the cost of what they estimate that the cost of home delivery is much cheaper than actually subsidizing fertilizer. So we have achieved the end goal with lesser cost because we are not assuming people are rational, and when we subsidize fertilizer, farmers would buy more fertilizer. Rather, we are understanding how actually farmers make this decision to buy fertilizer and exploiting that understanding to make policies. That's something which they did. That's one example of how we could use in agriculture. There is another interesting example. This might be interesting for those who are working in environmental economics. It's with nitrogen runoff. So nitrogen runoffs cause eutrophication. You know what happens to our lakes. Mainly eutrophication is a result of nitrogen runoff from agriculture fields. So we know that it damages our environment. So what would be the general assumption? Like, hey, go and educate farmers that fertilizer runoff would have eutrophication, which could affect you badly, and you could do that. Like, you could do that, but there are better, smart ways of doing it. Even like going and educating them, just providing that information. So this Pete and Mushoff, and they did a study in Europe, which in here, yeah, what they did was that rather than just sharing the information, they showed pictures of environmental health damage. They said nothing, just like showed pictures of like, this is a field with a lot of nitrogen, and this like a pond near it, how it looks like. Farmer might know it, but just showing it actually kind of nudges them. They tested it and they've seen that that has an influence. Rather than giving big lectures, sometimes what we say as a proverb, picture is worth 1,000 words. So many times this is also nudge. This we are using because we are much influenced by visual things rather than by words. There is another interesting study by Ashraf Nawa. It's actually about saving. We actually want to save a lot of money, right? But we are very bad at self-controlling. We actually we want to save, but we tend to spend a lot, end up saving less. So what they did was that provided people with saving accounts so that it has a lockup fund till a specific target is met, and they found out that that could help in saving. This is not agriculture per se, but yeah, it's something close to the rural development field. But that was an interesting study. Rather than giving education on savings are good for long run, there are other better ways of actually doing saving. I'll stop giving more examples here since it gets boring after some time. So like, yeah, fine. You're looked into, you understand now what those behavioral economics does, what those biases are, how they could be exploited. So from a researcher point of view, you might be thinking how to do that. Like as a researcher, how could I test this? If you understand how it's done, how could I do that? Like how these things are done. So if you see the slides, in the second point, I've written down the method they had used. It's randomized control trial, artifactual field experiments, again an RCT, randomized control trial. So what other methods we have to explore behavioral studies or test this behavioral principles? So this is a framework which I've adopted from some researcher. you might have learned about RCT from previous sessions, or you might have read about RCTs. Actually, RCTs are pretty expensive. From an Indian researcher, it is very challenging to actually do an RCT. It's pretty expensive. And most of these principles look very intuitive, like just change this, just tweak this would work. But it's very difficult to convince someone saying that just this tweaking this would work and not. Especially with policymakers, it's really challenging. So they always ask you that, do you have any proof it would work? That's the first question. Like what I know from having a small stint working with policymakers is that they always ask you, do you have any proof? So many times you actually need money to test it, right? So you're going to a policymaker to ask, give me some money so that I could test it. But they will always ask upfront for proofs. And you know that proving it is very challenging, right? So there is a framework which usually behavioral economists or people working in behavioral economics do. One is proof of principle. So we are trying to actually test whether this idea works in principle. So they used an approach called as controlled lab experiment. Lab experiments are a common approach used in marketing research. So what we are doing here is basically understanding whether this idea of like exploiting this behavioral insight work in theory. And that's what we're doing. We are testing it here. We'll discuss briefly how it's done. Second is proof of concept. What we do here is a controlled field experiment. So we are not doing an RCT. You understand by RCT, right? We're going to a farmer and doing it. The first case, which is set as lab experiment, is actually doing it in a lab. Lab here means social science labs are basically a room with a couple of individuals. In lab, basic lab setting, it's mostly with students. We'll discuss that later, but so you can progress in this manner. You could test the principle. If it's working in principle, you could test the concept. If it works well with concept, you can actually take it to the policymakers with the proof of concept and then ask for RCT money. That's one approach of a framework of doing it. Just give an idea about lab experiments. So like the biological scientists do with the lab, doing experiments on rat or fish or plants, we could do with humans. One established person who had actually promoted this work is Vernon Schmidt. He actually got Nobel Prize in 2002 for his laboratory experiments, using laboratory experiments as an empirical economic analysis. This is actually done. Lab experiments is a setting we do experiments with student volunteers as standard subjects. We could test a lot of these theories with students. How it's done, you could read about it, how lab experiments are done. Usually the setting is we bring number of students, we randomly divide into two groups and actually play set of games with one group as treatment and one as control, and see that how our principles are working or not. This is the easier setup, especially for academicians in universities, actually, because it's easy for you to get students around. So like I've seen very few studies which are exploited this, especially in our field. But you could do that. A lot of the principles which you think, we could test it with students and it could give you some basic idea. Rather than thinking that, hey, this could work, you could actually test it, right? It's easier said than done. That's the truth. But you could do that. Somebody who's interested, actually are working with universities and has challenges doing large studies outside the universities, mostly because of responsibilities or lack of fund. This is a good way or a good approach of doing it using lab experiment. It's cheaper, it's convenient, it's okay if you want to test principles and theories. That itself is a contribution to the literature, right? One of the criticism always people say about lab experiment is that as you are using students as standard subjects, they are not actual subjects. This could work in theory, but this may not work if you go to the farmers. That's the criticism often we have. But if you have multiple ideas, you could test it in lab and take the best idea you think is working to the farmers, right? That's a setup. What we use lab experiment. Another is called as artifactual field experiments. This is an interesting thing. You're doing the same setup. Like in a classroom, we brought students randomly divided into treatment and control group. You could actually do artifactual field experiments, which is called as actually bringing farmers into a class, divide them randomly into control and treatment groups, and play a game and look into do the same experiment. Here, one of the criticism what we had with lab experiment is that we are using standard subjects like students, but here actually we're doing with farmers, and we are testing our principle, right? Testing whether this idea would work or not. This is artifactual field experiment. Harrison and List actually have written a paper in about artifactual field experiments. You could read about it. It's an interesting paper which would give you a lot of interesting insights into it. So what we are doing here is actually validating what we got from lab experiments, the one which we had done before. We could, so if you had tested 3-4 ideas, you could validate with actual subjects here and see that is it working or not. This is a good point where actually, if you think it is working, you could take it to a policymaker, or you could pitch for an RCT, like, because RCTs are like very expensive, roll out in the actual field and do it with farmers. That's something to be done. That comes to the framed field experiments in RCT. I'm not going into RCT. You might have a session on RCT, but RCT itself is a separate session. But the principle is same. What we are doing in field is randomizing people into treatment and control groups and looking at the difference between them. Here, treatment is the principle what we are testing, or the idea which we are testing. That's it from my side, explaining about what behavioral economics is, what are the principles governing them, how they are used in policies, and actually how to do that. It's very brief. I just want to put an idea. There is something like that, and those who are interested could explore it further. I have a list of books and research papers which they have done that. You could go through them and see how you could fit your research into it, and is it possible to do that. Again, I recommend that, like, it's not about we have some method with us, so let's find this research around it, rather than find a problem, understand that problem, and think that is there something we could, the principles which you learned in behavioral economics, can we use these principles to actually do something about to solve the problem? That's one way of actually, that's the right way of looking into it. My experience is I've not still finished my study. I'm currently doing a study using these principles, but it's to be said, it sounds very easy, but it's a bit challenging. But it's very interesting. Those who have worked in field, it's pretty, like, it's close to like, hey, it makes sense kind of feeling when we do such a study. Thanks a lot, and now we can open for questions.
Okay, thank you. Very nice and mesmerizing talk. Not, got up from my seat because it was too good. It is always pleasing to listen to you.
Thank you, ma'am.
Yeah, really. So now, any questions there in chat box? Like one question is there. What type of research topics we can suggest to our students in behavioral economics? And then, of course, appreciations are there. You can see the chat box.
Okay, yeah, I'm just going through them. I'm just skimming through them. Thank you, guys. That's so nice of you. But something which I thought, like, I could have showed you with more data and example, but here it doesn't make sense, because these are not standard things. Something, just put it out, this is very contextual. Something which would work in one case may not work in other case. So showing an example doesn't make much sense. And actually testing them is very simple. You don't need even a complicated model to test it. It's basically t-test. or like the basic statistical test, which you all know. There's nothing complicated about it. The complication here is actually the idea and how actually developing something, how to test this idea, which is a bit complicated. So the question comes to Dr. Sangeeta asking what type of research topic we can suggest to the students. Something which something which I just want to put it out at this point of time is that one thing is that you should actually, something which we need in our basic education is to understand the subject as such. There is no ready-made questions to be answered, right? So that's not how we work with other research questions. If you run a logit, we could get an answer for something. No, it's not like that. Look into the problems as such and see that are we understanding this problems rightly? What are the kind of assumptions we are making? Especially rationality is a very strong assumptions we are making often in all our problems. As you see from the Esther Duflo study, we assume that if we incentivize farmer with subsidies, they will buy more subsidies. But they rather found out that rather than giving subsidies, if you actually deliver those fertilizer into their home, they will use more fertilizers. So that's something, an interesting insight which you could look into. So when you ask a student to find a problem, try to find, is there some insight like this? Like you could look into if there is something which you are missing from. Just look at a problem from a human perspective. That's what behavioral science does, and test it with students. Just teach them these principles. That could be something interesting for them. I'm pretty sure students could come up with good problems to test. That's what I could say at this point of time. Also read those papers. They are really interesting papers, and as I said before, they're very contextual. Something which worked in Kenya may or may not work in India. How economic field is now progressing is towards empirical research. So anything you'd say, you should test it and show it. So that gives a lot of scope for students to do, right? Even a small thing, if you do it, if you do a lab experiment itself, if you could do a small lab experiment, that itself is like worth exploring. At least at master's level, you could try an RCT for a PhD work. That's something interesting, I guess.
Great. Two more questions are there in chat box. One is yeah.
Sandeep's question.
Yes, he says Homo economics to Homo sapien concept.
In classical economics, this is given by Richard Thaler as like an explanation to distinguish what is a fundamental error we are making as an economist. We are trying to understand human based on a lot of assumptions. Like one assumption is rational, right? So economics assume human beings as rational. So they find humans from an economist sense, a rational sense. That's why he explained as Homo economicus, a human being which follows all the economic principles, what we assumed. But we know in reality, we are not that person, right? We are basically Homo sapiens. Homo sapiens is our scientific name. Like what we are we are with a lot of flaws. We have a lot of biases. So when we are designing policies for human being, we should not just look at us as Homo economicus, like a human being following all the economic principle. Rather than you should look at from a perspective of Homo sapiens as a human being per se. That's the explanation.
You can unshare your screen.
Yeah.
So you can unshare. Yes.
Okay.
Now participants can even open their videos if they feel like, so that you can have.
That explains it, Sandeep? Do you have a follow-up question on that?
No, another question is there. Dr. Pradeep, how is circular economy related to behavioral economics? That is
Dr. Pradeep, could you explain what you meant by circular economy here?
See whether he's there or not. Just wait. I have to see that he's in attendees or. Dr. Pradeep, you can unmute yourself and you can explain your question a bit, like you can interact. Dr. Pradeep, can you listen? Okay. It seems we are not audible to him.
Okay. But if you have any questions or queries, drop a mail.
Subhash, good to hear from you. How are you?
Thank you, sir. I'm good. How are you?
It was very nice presentation.
Thank you.
And thing is that how individual behaviors will impact policy. That's what you wanted to tell, I think.
Okay. So let me clarify a bit more on that. Like the fundamental premise what Adam Smith brings is that how every individual has their own behavior, and what we say as a social behavior is aggregation of all the individual behavior, and that's a fundamental premise actually Adam Smith built on. But after that, the economists how they build is that built on other assumptions, which is like, yeah, if that's the fundamental premise, everybody is rational, right? That's how we assume that everybody follows that set of principles. And so you make policies assuming that people are rational. If I give incentives, people are going to respond to that incentives. That's how assume and how we design policies, right? But in many cases, that's not true. That's my whole point. The individual behaviors actually change, and they are not consistent. Like the behavior they showed now may not be the same later, right? It depends on a lot of things. For this, we need to deeply understand how actually they make decision, rather than assuming assuming that they follow some pattern. And now we have tools and techniques to actually test it, how individuals behave, understand those patterns. If you understand those patterns using the tools or techniques which we used, you could then design policies based on those understandings. Am I on the right track, or you had something, some other different way of thinking, or you've been pointing out to something else altogether?
Thank you very much.
Yeah. Nice hearing you.
Yeah.
Here also. Good to see you.
Thank you.
So, any other question? Okay. So, in fact, I think you have explained the concepts of behavioral economics in a very innovative way. I mean, each concept, some cartoon was there. So it gives a picture of behavioral economics principle, like in the minds for a long way. You understood the behavior of the teaching kind of concept.
I don't know. I'm also trying to see if somebody got it or not.
Yeah. So it was really nice, as many people have expressed, to listen to these concepts. Even for me, like I thoroughly enjoyed your session. So I hope same with the participants here. So with that, we would like to thank you for.
Thank you, ma'am.
What time is it for you now there?
It's 12:30.
12:30. Okay.
Yeah.
Okay. It was early morning.
Yeah.
You started. Maybe you used clocky. picking you up. So it was nice to see the clock key and other things, simple solutions for complicated things. So really a good lecture.
Thank you.
Thank you very much. Thanks a lot for being here. Like it was long, after a long time we could hear.
Yes.
Yeah. So how is everything there?
Good.
Okay. So with that, we'd like to thank you again.
Yes.
So thanks a lot.
Thank you, ma'am.
Yeah. So
have a nice weekend.
Yeah, thank you.
Thank you.
Same
Thank
to
you, Shubha.
Thank you.
Thank you very much for a wonderful session and opportunity to see you after a long time.
Thank you, sir.
Yeah. And good luck for you.
Thank you, sir.
Thank you. So thank you all for attending this session on this weekend. So right now again,